Hi everyone, welcome back. In this video, we will discuss the top Kubernetes interview questions with full clear answers designed to help you crack real interviews confidently. Kubernetes is the industry standard platform for container orchestration. It automates deployment, scaling, monitoring, and management of containerized applications. Almost every modern microservices, cloud, DevOps, and distributed architecture relies on Kubernetes. In interviews, companies expect more than basic definitions. They want to know whether you understand how Kubernetes works internally, why it is used, and how it solves real production problems. Let's begin. What is Kubernetes and why is it used? Kubernetes is an open source container orchestration platform that automates deployment, scaling, load balancing, and management of containerized applications. Before Kubernetes, teams had to manually manage containers, handle crashes, reschedule workloads, and scale resources. Kubernetes solves these challenges by acting as a self-healing system. If a container fails, Kubernetes automatically restarts or replaces it. It distributes workloads across nodes, manages service discovery, and scales applications based on traffic or resource usage. Kubernetes is used because it ensures reliability, scalability, and portability. It works on AWS, Azure, GCP, on-premises data centers, and hybrid cloud setups. Organizations use Kubernetes to run microservices at scale, simplify DevOps pipelines, and reduce operational overhead. Next, what is a pod in Kubernetes? A pod is the smallest deployable unit in Kubernetes. It represents one or more tightly coupled containers that share storage, network identity, and configuration. Most pods contain a single application container, but in special cases, multiple containers may run together, such as a main app container paired with a logging or monitoring sidecar container. Pods are ephemeral, meaning they are not permanent. If a pod fails, Kubernetes replaces it with a new pod instead of fixing the existing one. This design ensures immutability and reliability. Understanding pods is crucial because all workloads in Kubernetes begin at the pod level. Deployments, replica sets, and stateful sets all manage pods behind the scenes. Next question: what is a deployment in Kubernetes? A deployment is a controller that manages the life cycle of pods. It ensures the correct number of pods are always running, performs rolling updates, handles rollbacks, and maintains the desired application state. When you scale a deployment, Kubernetes automatically adds or removes pods. Deployments make updates seamless by using rolling update strategy, meaning new pods are gradually introduced while old ones are terminated. If an update fails, Kubernetes can instantly roll back to the previous working version. In interviews, emphasize that deployments are used for stateless applications and are the most common resource type developers interact with in Kubernetes. Next, what is a service in Kubernetes? A service is a stable networking component that exposes a group of pods as a single endpoint. Since pods have dynamic IPs and may be recreated frequently, services provide a fixed, reliable way to reach them. Services handle load balancing between multiple pods, making sure traffic is evenly distributed. Kubernetes offers different service types, such as cluster IP for internal access, node port for external access, and load balancer for cloud provider integration. The key point in interviews is that services decouple application endpoints from pod lifecycles, ensuring clients always reach the correct backend. Next, what is a namespace in Kubernetes? A namespace is a logical partition inside a cluster that isolates resources. Large clusters use namespaces to separate applications, teams, or environments like dev, test, and production. Namespaces help manage access control, resource quotas, and organization. Two resources with the same name can exist in different namespaces without conflict. Interviewers expect you to explain that namespaces improve security, structure, and governance in multi-team Kubernetes environments. Next question, what is a replica set? A replica set ensures a specified number of pod replicas are running at all times. If a pod crashes or is deleted, the replica set creates a new one automatically. Deployments internally use replica sets for scaling and version management. Developers rarely interact with replica sets directly unless they need fine-grained control. The interview expectation is that you understand the relationship deployment replica set pods. Next, what is a stateful set and when is it used? Stateful set is used for applications that require stable identities, persistent storage, and ordered deployment. Examples include databases like MongoDB, Cassandra, and MySQL clusters. Unlike deployments, stateful sets do not treat pods as identical. Each pod gets a unique persistent identity and storage volume that remains stable even if the pod restarts. This consistency is essential for stateful workloads, making stateful sets a key concept for production systems. Next, what is ingress in Kubernetes? Ingress is a layer that manages external HTTP and HTTPS traffic into the cluster. Instead of exposing each service separately, Ingress provides a centralized route management system. It supports features like path routing, domain-based routing, TLS termination, and load balancing. In interviews, highlight that Ingress reduces complexity and cost by exposing multiple services through one endpoint. Next, what is a node in Kubernetes? A node is a worker machine that runs application pods. It can be a physical server or a virtual machine. Each node runs essential components like the kubele, container runtime, and kubeproxy to communicate with the cluster and host workloads. The Kubernetes control plane assigns pods to nodes based on resource availability, taints, tolerations, and affinity rules. In interviews, emphasize that nodes are where actual workloads run and are managed automatically by the scheduler. Next, what is the Kubernetes control plane? The control plane is the brain of Kubernetes. It manages cluster state, schedules pods, handles failover, and enforces policies. It includes components like the API server, scheduler, controller manager, and AT. The API server is the entry point for all commands. AT stores cluster configuration. The scheduler assigns pods to nodes. Controller manager ensures the desired state is maintained. Interviewers expect you to understand that the control plane ensures the cluster operates correctly and continuously maintains the desired state. Next, what is etcd in Kubernetes? etcd is a distributed key-value store used to store cluster state and configuration data. It contains information about nodes, pods, services, secrets, config maps, and all cluster metadata. Kubernetes relies on etcd for consistency and reliability. If etcd fails, the cluster cannot function because the control plane loses its source of truth. In interviews, mention that etcd must be backed up regularly to avoid catastrophic failures. Next, what are config maps and secrets? Config maps store non-sensitive configuration data such as URLs, environment variables, and settings. Secrets store sensitive data such as passwords, certificates, and tokens. Both allow externalizing configuration from application code, making deployments flexible and secure. Secrets use base 64 encoding and can be encrypted for additional safety. Interviewers expect you to highlight the difference: config maps for normal config, secrets for sensitive data. Next, what is horizontal pod autoscaling? HPA. HPA automatically increases or decreases the number of pods based on CPU usage, memory usage, or custom metrics. Autoscaling ensures applications remain responsive during peak loads and cost-efficient during idle times. Interviewers expect you to say that HPA is crucial for elastic cloud-native applications. Next question, what is a daemon set? A daemon set ensures that every node in the cluster runs exactly one instance of a particular pod. It is commonly used for system-level workloads like logging agents, monitoring tools, or networking components. When new nodes are added, daemon sets automatically deploy the pod on those nodes. This ensures cluster-wide background services run consistently. Next, what is the difference between Kubernetes and Docker Swarm? Kubernetes is a feature-rich enterprise-grade orchestration platform, while Docker Swarm is simpler but far less powerful. Kubernetes offers advanced features such as autoscaling, self-healing, rolling updates, service mesh support, secret management, and multi-node scheduling. Docker Swarm is easier to set up but lacks deep control and ecosystem support. In interviews, emphasize that Kubernetes is the industry standard for large-scale deployments. That's it. These top 15 questions cover the foundational concepts companies expect you to know, from pods and deployments to autoscaling and stateful workloads. Kubernetes is one of the most essential skills for modern backend developers, DevOps engineers, and cloud architects. Mastering these answers will help you confidently clear Kubernetes rounds in real interviews.